recommend you write, oh, that's how you 2.5, part 2. Go ahead and write down this slide. Complex conjugates occur in pairs. So an example, if you have 3 plus 2i is a given 0, then you must also have 3 minus 2i. So that's what's going to help us with this problem. Sure can. So here's our next example. They tell us that we have a 4th degree polynomial, and they give us 3 out of our 4 zeros. And we want to come up with what would be the equation for this function. So we have 2 real zeros, so those will be x-intercepts at -1 and -1, which is a repeated 0. It's a multiplicity of 2. We talked about that earlier in chapter 2. And then we have a complex 0 of 3i. What is going to be the other 0, the last 0 then? -3i. From that last slide, they occur in pairs. So now we know the 4th 0. If you have 3i, then you must also have -3i because they occur in pairs. So now we know all 4 zeros. 2 of them are real, 2 are imaginary. So you only have up to 2 x-intercepts. In this case, you really only have 1 x-intercept because it's a repeated 0. So now we're going to go out and write that function out. We want it to be 4th degree, so we have some multiplying to do. So you're going to help me fill it in as a function in factored form. And I have 4 parentheses. What's going to go in those parentheses in factored form? X plus 1, x plus 1. That takes care of these two. It's always opposite. X plus 3i. And then x minus 3i. So now we have it in factored form. But it asks us for a 4th degree polynomial. So we have to then get it into the 4th power. So we have some multiplying to do. So my recommendation, since you have 4 parentheses, is to group kind of like parts together. So I would probably recommend that you multiply these 2 together first, foiling them, and then foil these 2 and use the distributive property. So let's foil first x plus 1 and x plus 1. So we get x squared plus 1x plus 1x plus 1. Okay, so that took care of multiplying x plus 1 and x plus 1. Then we'll go over and multiply the complex zeros, factors. And we learned a little thing yesterday, a little shortcut. When you multiply complex conjugates, what happens to the middle terms? They cancel out, so we save ourselves a little bit of time. So I foil the x plus 3i and the x minus 3i. So I only have to worry about the first and the last. The middle terms cancel out. Now I'm just going to clean up the two parentheses, the blue and the red. So I have like terms in the blue. So now 1x and 1x is 2x. And then in the blue, what happens to that negative 9i squared?
I squared root of 3.
I squared of 3?
I squared root of 3.
Nope.
Squared changes to a negative.
Yep, drop the I squared, change the sign of the negative. So it's a plus 9. Now we have a trinomial times a binomial. We can't FOIL anymore, but we can still distribute. So how the distributive property works is I take every term in the red and multiply it to every term in the blue. And these you have to be careful with. Do you like the arrows or can you do it without the arrows? The arrows where you kind of go like this. Like that, when you show it. I know, it's okay. So x squared times x squared is x to the 4th. X squared times 9 is 9x squared. Then I'll take the second term, 2x, and multiply it to those two. So 2x times x squared is 2x cubed. And then 2x times 9 is 18x. And then my last one, 1 times x squared is x squared. And then 1 times 9 is 9. Now I just have to clean up any like terms and make sure it's in descending order, so it's standard form. So I have x to the 4th. The next highest term is 2x cubed. And then I have like terms with 9x squared and 1x squared to give us 10x squared. And then 18x, and then plus 9. There is my function in standard form. If I asked you to find the rational zeros, using the rational zero test if possible, what would you say? Factors of 9 over the factors of 1, which would be plus or minus 9, plus or minus 3, plus or minus 1. In this case, only one of them existed, the negative 1. All right. Next example. This is our last example. I'm going to stop the recording, and then we'll have one more video.